So, I'm recording this Sunday before the Falcons play the Packers. So I hope that you guys are watching this in terms of us being successful. We're going to the Super Bowl! If not, ignore this part of the video and you're all going to fail. Alright, enough of that. This is where I really wanted to go after we did graphing quadratic equations or graphing parabolas. We have to know how to deal with this. I gave you guys multiplying polynomials as kind of as a stopgap until I had enough time to make these notes. I thought I had some, but obviously I didn't. So let's get right into it. Now, before we do, there's a couple of different aspects to this. First, we need to know how to deal with negative numbers underneath the radical or the square root sign. It's okay if it's a cube root, which means there's a number right here. The index is 3. But for a square root, whenever it looks like this with no number, when I say the radical looks like this with no number out here, we understand that to be a square root. Whenever we have a square root and there's a negative number underneath the radical, we have to know how to deal with that. And these are called complex numbers. Complex numbers are a combination of imaginary and real parts. All right, there might be some things that I say that I didn't actually have written down here. So you want to pause and make sure that if I say something that's a need to you, that you actually use it, write it down, because these are some old notes that I found that I can just use for examples. All right, let's get straight into it. First of all, what I really equals is the square root of negative 1. All right, so let's talk about how to simplify radicals square roots whenever we have a negative number underneath the radical. So we're going to go straight to this hint right here. When you get a negative underneath the radical, simplify by using the imaginary I. Now, how do you do that? Separate, and that should be a square root right there. So in your notes, make sure you write the square root of negative 1. It didn't carry over. So the square root of negative 1 from the number and replace it with I. Then simplify the radical. I goes in front of the radical. So what we're basically saying there is we're going to separate the square root of negative 1 from the positive number. So let's look and see what I'm actually talking about. All right, so got these 3 problems here. I want to simplify. All right, say you're working your problem, and up to this point, once we got a negative number underneath the radical, we just kind of stop. We understand that we have an imaginary number, but we actually can simplify our answer just a little bit further. And so the notes basically said, or the hint in the notes said to do this. There's a property in math that allows you to do this. And what that really means is that you can separate like that. So notice I just basically separated the negative square root of negative 1, or the negative number, away from the square root. Now, we just saw that that really equals I. The square root of negative 1 really equals I. Now, this you can actually put in your calculator in order to simplify your square root. This you can actually put in your calculator, and when you do it, you get 2 square root of 6. When you put that in your calculator and hit enter, it'll simplify or simplify square root of 24 into 2 radical 6. Okay, if you put this in your calculator, it's not going to work. But you can do this. Now, how do you write this as your answer? Because that's not your answer. I just boxed it, but I'm showing you the proper way to write that is 2i square root of 6. That's normally how you would see that written. All right. Sometimes the I is after the radical, like that, but I don't see that often. This is the normal way to write your answer. All right, let's look at number 2. Number 2, notice I have the square root of negative 36. Now, if that negative wasn't there, then all we would say is that equals 6. But I can't put that in the calculator. It won't allow me to. But if I go ahead and separate square root of negative 1 and the square root of 36, I know that equals 6, and that equals I. Again, the way you want to write your answers is to make sure that your constant number is always in front of your imaginary number or the I symbol. See how the constant, that means the actual whole number is in front of the I. All right. And so that will be the answer. So the basic idea is ignore the negative sign, put that in your calculator, and make sure you put an I in your answer. Now, I suggest going this route because if you don't, you're probably going to forget to put the I in there. And as I say that and warn you, you're not going to listen, most of y'all. Now, look at number 3. Number 3 is a little bit different. What's different about number 3? I'll wait. Like Dora, like I can hear you talking back to me. The negative is not underneath the radical. The negative is outside. So don't get confused on stuff like this. Okay, phone's talking. Don't get confused on stuff like this. This, you can actually put in your calculator. But this basically means is I want the negative or the opposite of whatever the square root of 12 simplifies down to. If you put that in your calculator, the square root of 12 is going to give you 2 radical 3. And so your answer is negative 2 radical 3 with no I, because this is not an imaginary number, because the negative is not underneath the radical sign. The next thing we really need to focus on after simplifying radicals is, or square roots, is this section right here. I call this my eye chart. I don't know if it has a real name, but I call it my eye chart. And basically the eye chart is, notice that this is I to the first, I squared, I cubed, and I to the 4th power. Each one of these basically repeat in the cycle. 1, 2, 3, 4. And then once I start off with 5, like I to the 5th, it'll start right back up here. I to the 6th, I to the 7th, I to the 8th, I to the 9th, I to the 10th, I to the 11th, I to the 12th. You can kind of get the same pattern over and over and over and over and over and over again. Another thing, I cubed, another way to write I cubed is negative I. So you can write out here equals negative I. That's another way to write I cubed. You'll see that a lot. In fact, it's probably the way you see it the most. So another thing you need to write here is equal negative I, equals negative I. So here's a hint. To simplify I to a power, okay, this is telling you what to do here. Find the largest multiple of 4 in the power, subtract it away, then you'll be able to see your answer using the eye chart. In plain English, I'm going to take the biggest multiple of 4 out. Why? Because that just equals 1. It's going to be 1 times whatever's left over. And what's left over should be one of these right here, or just 1. So if we divide out the biggest multiple of 4, that means any multiple of 4, 4 times 1, 4 times 2, 4 times 10, and 4 times 100, whatever. The biggest multiple of 4, subtract that away, and whatever's left over should be one of these. I first, I squared, I cubed. So let's take a look at these examples here and see if we can make some sense of this. Now, guys, don't let this be super confusing. This can be easy if you allow it to be, if you turn on your old school thinking caps. All right, if you look at the chart, this is actually on the chart. That actually equals 1. I to the 4th equals 1. And so that's cool if the problem they give you is actually on the chart. By the way, if I make this problem up, what does this actually equal now? It would equal 5, correct? Just kind of throwing that out there. That's not the problem. I just kind of want y'all to don't forget basic computation. I to the 6th is not on the chart. So basically what I'm going to do is separate or subtract out the biggest factor, the biggest multiple of I to the 4th. Now if you go back to your exponent properties, you'll remember that if you got the same base and you multiply, you add their exponents. So I to the 6th really is I to the 4 times I squared. Now why did I do I to the 4 times I squared? Because 4 is the biggest multiple of 4 that's inside 6. This is basically 1 times I squared. And what is I squared according to the chart? Look at your chart. That actually equals negative 1. So 1 times negative 1 is simply negative 1. So basically, you don't even need this part. It's not necessary. Once you factor out the negative, once you get rid of the I to the 4th biggest multiple, then all you have left over, what's going to be your answer, is over here. Look at number 6. See, I know because I understand numbers. I just keep going back from 37. The next number from 37 is 36. And I know 4 is a multiple of 36. And so I write I to the 36 times I to the first power. Now, why do I separate that out? This is the important part, guys. I to any multiple of 4 equals 1. That's why I keep doing it. That's why I didn't go to I to the 35. I can't go to 38 because it has to be less than that. 36 plus 1 is 37. So that basically is 1, and I don't need that. So I to the first equals the square root of negative 1, and you just keep it as either one of those right now because that goes away. Now notice I to the 100 is actually a multiple of 4. 4 can go into 100 evenly. So that also equals 1. So the idea, the short version that you need to make sure you understand is that this cycle repeats itself over and over and over. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That's why if I got I to the 12th, it's going to equal 1. 13, 14, 15, 16. I to the 16th is going to equal 1. But I to the 17th is this one. I to the 18th. I to the 19th. I to the 20th. And so that's why I'm factoring out or dividing out a 1 on everything. The last thing we need to talk about is simplifying I statements like this. And so for the sake of time, you might see me speed up some and just jump straight to the answer and not go through all the work. Hopefully you can copy that down and get questions asked or answered. Guys, don't forget tutoring, man. Y'all need to take advantage of tutoring at the rec. Y'all know where I am on Tuesdays and Thursdays. Let's get straight into it. Here's the hint. Treat I like any other variable, like X, Y, Z, which means we can add, subtract, multiply, divide, whatever we need to do. And if we ever get a power of I, like I squared, cubed, or something like that, to the 4th, we need to make sure we simplify that, all right? So we can add and subtract and multiply I. It is like a variable. So with that in mind, let's go ahead and do these last few examples here. All right, starting with number 8. Again, I might have to fast forward these, but I'll start with this one real quick. So the idea is I'm adding here. All right, so you add like terms. If it's a plus sign, you don't have to worry about anything. 6 plus 7 is 13, and 3i minus 8i is negative 5i. And notice how I wrote my answer. And look at this thing right here. It says a plus bi. I didn't write that in the notes, but it's important that you make sure all your answers, if it's a complex, that's where you get the complex idea. If you get the complex number like this, it's always the whole number minus or plus the imaginary part. All right, that's how you want to write your answer. Negative 5i plus 13 is the same thing, but it's not the correct form. So I'm going to go ahead and do number 9 and work that one, and you can see the answer. Only thing I would just mention as you look at the work is this right here means each sign changes. Not that they're both always going to come positive. It's just that these are both negative, so they change to a positive. If one of them is positive and negative, you know, they're just going to change because of that. I didn't change signs over here because the plus sign don't mean change signs. Now let's look at number 10. Is this add, subtract? No, this is multiply. So number times number, I times I. So I get 20i squared, but I don't want to leave it as I squared. I already know that I squared is really negative 1, so this is 20 times negative 1, which equals negative 20. You're going to see I squared pop up a lot, and all that means is change the sign. So if that was a negative 20, that would become a positive 20. That's all. Now look at number 11. And again, for the sake of time, I need to go ahead and work this, but that's a FOIL, right? You should recognize it. I don't care if it's an I. 2 terms times 2 terms, we just multiply a polynomial, so you should understand that, and that's a FOIL. Okay, I'm going to run out of time, so let me explain this quick. FOIL, make sure when you do the last two, that's I squared, keep your signs. Everything else should be self-explanatory. 6 times 7 and 6 times negative 8i and so on to get those two, and those two combine to be that. But notice here, this simplifies down to negative 1. So negative 1 times negative 24 is a positive 24. So you don't stop here. Notice that those two are like terms, 42 and 24, and you get this. Look at number 12. Here, follow the steps, guys. Follow the steps and you'll get it. I'm trying to rush because I'm about to run out of time. And if you got questions, come to tutoring or hit me up on Google Classroom.